The next question of coaching starters 110 is monsters.
In this question, we have a monster which has an initial health of H, right? Then is a person who is fighting this monster, and he has a move, basically two types of moves with which he can attack this monster. First is the regular move. The other one is a special move, right? In regular move, what happens is initially we have something called attack power. Right? Initially, there is something called attack power, and when we apply this regular move, we'll have to attack this monster with this attack power. Initially, attack power is set to 1, right?
Yeah.
But when we use this regular move, after using the regular move, attack power becomes double of the previous attack power, right? Next time when we attack, the attack power becomes 2. Next time again when we attack power becomes 4.
Yeah.
After that it becomes 8. After that it becomes 16. Right? It doubles after every regular move, right? And there is one more move called special move, and this special move is actually using this attack power exactly 16. If it is 16, then our health of the monster will reduce by 16, but there will be no change in the attack power after using this special power, right? And it is also given that special power can be used at most 1. And we have to actually basically minimize the number of moves required to actually give, or we can say attack, H number of points. And we need to reduce the power or health of the monster exactly H units.
Yeah.
Right? It cannot be more than H unit. So we should make sure that our moves are chosen in such a way that the attack, like the minimum number of moves we are using to reduce exactly H number of points for the monster.
Yeah.
Right? There is a question. If it is not possible for us to get exactly H number of points, to reduce exactly H number of points to the monster, we have to grid minus, which says it is impossible to kill that particular monster.
Yeah.
If you see the constraints say that test cases are from 1 to 1000. And if we look at the health, then health is given as it will be always in the range of 1 to 10 power 6. That is the question.
Yeah. So now, if we observe the operations, H is our health, right? So to reduce H, operations that we can perform can be 2 power 0 plus 2 power 1 plus 2 power 2. As if we see in the first strike, health will reduce by 1. In the second strike, it will reduce by 2. As Ben's attack power will increase, will double after each attack. So that is why the sequence of damage points would look like this: 2 power 0 plus 2 power 1 plus 2 power 2 plus so on plus some 2 power x plus h minus 2 power 0 plus 2 power 1 plus so on 2 power x. And this should be a prime. And one more thing, we might or might not include this because this is some points that we get when we use a special point. And we might or might not use that special. If we use, we can only use once, or we shouldn't use it. So if we use it once, then these many points can get added, and this should be a prime. Then only it gets added. So now what we can do is we can do a brute force. If we analyze x can be something in the range 0 to 20. This claim is because if we check 2 power 20, 2 power 20 will be greater than 10 power. So it is useless going beyond 2 power. So at max till 20 we can just consider. Now what we can do is we can do a brute force for a fixed x. Firstly, before that, what will be the value of this? This number can be in the range 0 to 10 power 6 because h is 10 power 6 and we don't pick this value, we don't, we'll ensure that this value, whatever we are subtracting, that is always greater than or equal to. So that is why it would be in the range 0 to 10 power 6.
It is greater than or equal to h.
Sorry, lesser than or equal to h. So that is why it would be in the range 0 to 10 power 6, as h value is 0 to 10 power 6. Now we should just find out how many primes are there in this. For that, we can run standard sieves, run a sieves, and mark all the prime factors in this. So, prime factors, not prime factors. Mark all the primes, all primes in this 0 to 10 power 6. Now, and that can be done in 10 power 6 log 2 of log 2 of 10 power 6. So in this complexity, we just computed everything before the test case. Now for test case, let's see how we can solve the problem. Fix a particular x in the range 0 to 20. Firstly, handle the case. If h itself is a prime, then number of operations we need are 1. Right? So this case can be handled, and h can never be 0. Now the way we can remove h is either by performing only type 1 operations, that is just attacking, or by performing one special move and then attacking on. So for that, what we can do is we fixed x, so we can maintain the sum. S represents what is the sum from 2 power 0 plus 2 power 1, so on till 2 power x for a fixed x. So this can be done while running the loop. So once we have this, we can just do a brute force. If firstly, if h first situation is at a point h can go greater than s can go greater than h, then this is useless. Here we can just terminate. As from here we know that we can never reach exactly h. As we increase x, s value will increase. It won't decrease. So now other scenario is if h is exactly equal to s, then number of operations we need are x plus 1. Right? And okay, is it and now one more scenario is if let's just say if this is a prime, this is some function, this is some array of sieves. Let's say is prime marks all the numbers in the range 0 to 10 power 6 as true or false. If it's a prime, it will be true or it will be false. So now after performing type 1 attacks x plus 1 number of times, if the leftover part, whatever we have, and this should be else if, because if it is exactly equal, then however 0 won't be called a prime. So if this is not the scenario, then we want to know if the current number is a prime or not. If it is a prime, then we can perform one special move which we have. So h minus s, if this is a prime, then number of operations we need are x plus 2. X plus 1 operations, x plus 1 operations we used type 1 move and one operation for the special move. So that is why it's x plus 2. Now, because we just run till 20, we can just find out the minimum of all these operations which are valid, and that will be our answer.
So my question to you is, after performing the special move, can we continue the operations or should we stop it? Here we are checking that from first X moves. In first X moves, we have done some damage to the monster. After that, if the remaining power left in the monster is a prime number, that will perform the special move. But what if after performing the special move, still there is some power left?
Okay, so here after performing the special move, from this there won't be any power left because this is the complete power that is left. So if the left power is a prime number, then only
we are performing
the special. Because here the claim is no matter which operation we perform first, that doesn't exist. So it is always optimal to perform the prime operation first and then the current operation, or we can even perform the current operation then the prime operation. So current operation means if we perform move one once, then it will be 2 power 0. Then attack got doubled, it's 2 power 1. Now if we perform prime, the prime operation, that is move 2. Then if we perform this, still the delta remains the same. If we are. So no matter when we perform this prime operation, still whatever result we get, that will be the same. So as the order of performing the special move doesn't matter, we assume that we are always performing the special move at the end after performing all type of.
My question is like what we are doing first to power 0, first to power 1, first to power 2, first to power 3, all the way up to power x. After that, the remaining power that we have for the monster, if it is not a prime number, then what will be the case?
If it is not a prime number, then we increase to power 1.
What if after increasing we are not able to reach x? Or we are not able to reach h? If we increase the power up to.
So here, we know that these operations, these many operations need to be performed depending on the case work. Now, if we observe one thing what we can do is we can iterate the loop completely, find the minimum operation, right? Take a variable, find out the minimum. Or one more thing is once some of the cases true, we can break it there. That is because if we observe as we move beyond x value, x value will only increase, it will never decrease, right? Because x is increasing. If we found the answer in previous x step, then it's always then for sure that x will be the best choice. Right? Otherwise, we can just if we don't find anything, we can continue until we find. Now there can be a scenario where it's impossible to reach h. So after performing all this, still we couldn't reach h, and there is a point where s reached greater than h, but we didn't find any prime. We didn't find the health to become a prime at any point, or we didn't find the health to become equal to s. Then we can say that it is impossible to reach h. As we just saw, the h equation looks as follows. It is adding up some 2 powers till 2 power x and then a prime number. If it won't satisfy this form, then we can guarantee it's impossible to reach h with the given operation. Exactly h with the given operation. So if none of them, if we find none of them in this, I mean none of the casework gets executed, then we can say it's minus. That is, it's impossible to reach exactly h. So now if we look over the time complexity of this, time complexity of this would be big of, firstly we are doing sieves. So it's 10 power 6 log 2 of log base 2 of 10 power 6. This is for sieves. Plus we can say it would be log 2 of n per test case. And I'll just write into t because here test cases will appear. N have no constraint on the test case. So this is the time complexity including test cases. And the space complexity is big of 10 power 6 as we maintain a 10 power 6 array to compute
prime numbers.
Yeah, to mark all the prime numbers in the range 0 to 10. So this way we can solve it.